to be able to check these very quickly. You can ping it and see like, oh, is this OPA up? Is it not? Respawn it, create a new one. Then the discovery API, every now and then there might be a need to refresh the configuration. You might tell it to pull down the new bundle, or you might tell it to do something, right? So that discovery API allows you to tell the OPA what to do. Cool. And with that, that's the general high-level overview of what OPA does, how to decouple the policy decision from the policy enforcement, right? And so now we're going to be talking about our first use case here, which is HTTP and API, right? Being able to make these API calls securely. So we're going to be looking at a imaginary service here called the salary service, right? And so it's the same decision tree here, right? So this is our example policy written in human language. Users may read their own salary and the salary of anyone who reports to them. So we see on the right here, we're trying to call get/salary/Bob. So we're trying to find out Bob's salary, right? That salary service is going to call out to OPA with that post.http/auth/allow. OPA then reviews the policies, reviews the data that it has, and then sends back a true false. So let's see. Right on the left here, we see the input, right, which is that GET request. On the path, salary/Bob, and the user making the request is Bob, right? So now we see this salary service is now making this query, and OPA is going to respond back, right? But before OPA can respond back, OPA has to compare the input query with the policy that it has, right? And so here we see that the policy rule states that allow equals true when, right, the input method is get, the input path is salary, and then we're taking this user variable and then we're using it across the bottom line as well, which is the input user has to be equal to the user as well, right? And so here we can see that Bob is requesting Bob's salary. So we're going to expect this to pass, right? And so now let's look at this again. Let's change out the user. Let's say that now we have Alice. Alice wants to request /salary/Bob, right? So this is no longer Alice's Alice's salary. So now we can see that this request, Rego is going to look at this and say, oh, you know what? That actually doesn't work. Alice, you cannot see Bob's salary. But remember, there is a second part to our policy here, which is the salary of anyone who reports to them, right? So this is where that data payload comes in. So now all of a sudden, right, we want to check that the manager of Alice, right? And so this is exactly how you would pass this data in, right? This is a JSON object that we could pass in. So we're passing in an object manager of, right? So the manager of Bob is Alice, right? And so now we're going to add another rule to Rego. And here we see the top rule, which we evaluated last time to false, right? So that was not true. So now either allow equals true if this, or allow equals true if this next set of rules comes into play and is true, right? And so the big difference here now is input user equals data manager of the user the user in the path, right? And so now we see evaluates to Bob, the user evaluates to Bob, and the manager of Bob evaluates to Alice, right? And so now Alice is able to successfully request down the salary of Bob, right? And so that kind of shows you the simplicity of what Rego looks like, right? Like it's not ultra complex. Like you can add more things, you can use the built-in functions, you can expand this in a number of ways, but overall it is designed to be fairly simple looking and fairly easy to read, right? And then so just with the Rego and the JSON smashed together, giving OPA a very quick way to respond to a request to see how something works. Move on to the next use case here, Kubernetes, right? I'm sure everyone's here is somewhat familiar with Kubernetes. So we're going to look at a very standard request here, right? We have the user all the way on the left-hand side, right? User's trying to do kubectl, apply file, app.yaml, Right, and so this command gets passed all the way through through these modules before eventually being stored in etcd. Right, so it gets the user's authentication gets checked. It goes through some sort of authorization, then mutating and validating admission controllers. Right, and so these modules are also chainable. Right, you could have more than one that it's being configured for, and then right, these all come with some number of built-in functions that work with them, right? Like your authentication, maybe a static token, service account, OpenID Connect, right? Authorization, maybe RBAC, ABAC, things that we're all very familiar with, right? Then when it hits the mutating admission controller, this could be changing the request to set specific parameters, like always pull the image. And then lastly, right, you might be doing the validating admission controller, which is setting certain limitations, right? And so what was cool about Kubernetes, I forgot what version exactly this was added, but they realized that, hey, sometimes you want to do more than just more than the functions that are built in, right? And so they created this option to do webhooks, right? So now each of these components, right, can reach outwards to ask what can or cannot happen, or reach outwards to ask for more data, or reach outwards, right, to send this webhook before completing an action, right? And so for OPA, which works as which can be called upon, right? This works very well, right? So now these different modules can instead of reaching outwards to some other service, right? They can reach outwards to OPA and say, hey, OPA, I want to do something specific. Can you tell me, can this happen or can this not happen? Can you pass the data back that I'm looking for, right? And so specifically, we're going to look at validating admission controller, right? This is a very popular one for OPA users, right? There's a bunch of community members already doing this, right? And so with setting OPA as the validating admission controller webhook, right, you're able to do a lot of things, right? So these are some very common ones. You might want to restrict it to a certain Docker registry. You may want to require labels on your resources to make sure that they're being assigned properly, or they're being billed properly, or whatever else, right? You might want to do set specific unique paths, or you might want to deny or allow HTTP. You may want to set resources, replace pod security policies, anything really. So, and then with that, let's just look at a very simple example here. On the left-hand side, right, we have the input here, and so this input shows what we're trying to create with what we're trying to create in the Kubernetes cluster. Right, and so this input data, this is going to be passed to OPA and Rego, or it's going to be passed into OPA, right? This shows that we're trying to create a pod v1. We are setting the metadata as name my app, and inside of this pod, we have two containers. We have an Nginx container, which is called Nginx frontend, and we have a MySQL container called MySQL backend, right? And so OPA is then going to receive this input data. It's going to compare it to this Rego policy on the screen, which shows that, right, there is a package Kubernetes validating and a package just a collection of rules for easy organization, right? And so the rule itself is deny. Deny is assigned a message when these two lines evaluate to true, right? And so we have a not in front of this line, which means that this is not true, then this line is true. And so we have the input file on the left, right? The request top level key, objects, metadata, labels, right? So we have object, we have metadata, we have no labels defined inside of this, right? And so we have no labels, we don't have a cost center label. So now, right, that not line is true. So it moves into the message that is assigned, right? And the message here is that every resource must have a cost center label. So this rule now evaluates to true. The deny block is assigned this message and return as the response to Kubernetes. So Kubernetes now says, hey, this is what I received when trying to create this object. Here's your deny message, right? So you can easily pass this back to the user trying to create the pod here and say, hey, you did not create your cost center labels. This is the policy that's being enforced, right? So it's very clear, very concise what needs to happen, and they can modify their YAML and try again. Right. And so if you want to get started with OPA, right, some quick tips here, right? Like we have a pretty big community. We have over 200 contributors. We have 50 integrations with cloud native tools, 5,000 GitHub stars, 4,900 Slack members. Once again, I'm always in that Slack channel, so you can always say hi to me. We have 100 million Docker pools and a huge ecosystem of tooling around OPA, right? We have Comptest for validating policies. We have Gatekeeper for creating custom CRDs in Kubernetes. We have plugins for pretty much most IDEs, VS Code, IntelliJ. Pretty sure there's one for Vim and a bunch of other things. Let's see, and then some of our integrations, as I stated, Kubernetes, a lot of service meshes, one for Docker, a very simple one, which was like SSH and sudo, which is actually very popular. Some people have a lot of servers out there that still need some sort of policy to protect their servers from bad SSH attempts. And then Terraform, which I stated earlier. And so this is another very popular one because when you're applying manifests, right, there's a bunch of things that can happen, can go wrong. You could create a bunch of resources. So you may want to restrict that in some way. And right, like you can, with OPA, right, it's very flexible. So you can do this in a bunch of different ways. One interesting way I've seen this done is kind of setting point values to like changes. So creating an EC2 instance might be like 5 points, destroying a cluster might be 100 points, right? And so you can have like some level of point system. And then based on the number of points that this request costs, right? Then you could be like, oh, this is a big change. You need X, Y, and Z evaluated beforehand, right? Like, so you could get very creative and not just very creative in how you do this. And so you could come up with a fun solution, right? And it's also pretty widely adopted. We have a bunch of big players. Netflix uses it for gRPC validation. Big cloud providers, I think like the 3 big ones now use it in their managed Kubernetes offerings. And then, we also have large banks using it for like data and risk management options. So yeah, and then some quick tips here, right? When you are getting started, start small, figure out how to write your first policy, protect your first endpoint, and then kind of just build on top of that. Right, browse the OPA documentation. As I said, there's a bunch of functions already. You may see a function that solves a very particular need for you. So you might just want to like run with some of those functions that can fix an easy problem for you at first, and then build on top of that, right? And then as you're scaling out, then you'll want to scale up, start using the OPA management APIs, and start building on top of what you're doing to make things much more clean and concise. And then Styra has a couple free tools here. The Styra Academy is an easy way to pick up and learn Rego. It is a full language, so there are a lot of things to learn, which is why Styra created the Styra Academy, to kind of go through all of the different functions and things you can do with Rego to learn it. Like I said, it's free. And then there's also Styra DAS, which is like an IDE control plane for OPA. It allows you to author policies and control your OPAs. It's also free. There's some free level of it. And then the OPA Slack community. My team is very responsive and open to questions. And so thank you. That is securing your cloud native applications. Okay, thanks.